This is Dr. Kavita Singh, Associate Professor, Department of Civil Engineering, Institute of Aeronautical Engineering. So, from this course, Remote Sensing GIS, today our topic will be scale of aerial photograph. So, we are going to discuss how to determine the scale of the aerial photograph, how can we find the scale of the aerial photograph, and what are the different ways we can get to know about the flying height with the help of the scale. So, let us enter to this topic. So in this topic, we'll be just discussing about scale of the aerial photograph, different ways to determine scale, methods to find the scale of the aerial photograph, examples to find the flying height. So this all contents we are going to discuss today. So first thing, let us discuss about the scale of the photograph. So what is the scale of the photograph? Let us know. The scale of an aerial photograph refers to the ratio of the distance on the photograph to the corresponding distance on the Earth's surface. That means that if you have a 1 centimeter on the photo, so the same distance on the ground, it can be in kilometers, maybe in 1 kilometers, maybe 2 kilometers, maybe 3 kilometers, that depending on the scale, how the scale we decide. So that 1 centimeter on the photo is equal to 1 kilometer on the ground. So this is how we define the scale, that distance on the photograph to the corresponding distance on the ground surface. So it is typically expressed as a fraction or ratio such as 1:10,000. This is one example we have given here, 1:10,000 or 1/10,000. So here as fraction or ratio, if we talk about ratio, then the scale is determined as 1:10,000, or if we tell about the fraction, 1:10,000. So for example, in 1:10,000 scale, aerial photograph, 1 unit of the photograph represents 10,000 units on the actual ground. That means 1 unit on the photograph, same unit will be representing on the ground as 10,000 units. Okay. So if you measure a distance of 1 centimeter, on the ground on the photograph, it would correspond to 10,000 centimeters or 100 meters on the ground. So this is how we define the scale of the photograph. Now, different scales are used for aerial photographs depending on the purpose and details required for a specific applications. So large scale aerial photograph, example 1:5,000. So provide a more detail but covers smaller area. While small scale aerial photograph, for example 1:50,000. Cover large area but less details. This means that actually it is reverse. When we call it as large scale map, that means the area coverage is less always, but the details will be more. When we call it as small scale, the area coverage will be more and the details will be less. So this is how we define the large scale and small scale. So examples for large and small scale is 1:5,000 is always called as large scale. When it is 1:2,000, this is also large scale. 1:1,000, this is also large scale. Now, if it is 1:10,000, so this is also large scale compared to 1:25,000. If it is 1:25,000, so this 25,000 will be small scale and 10,000 will be large scale. So this is how we define the scale as small and large. So whenever you are talking about a large scale map, so the scale will be less in number, like 1:1,000, 1:1,000, 1:2,000, 1:5,000. So this is how we get more details in that. And when you talk about the small scale, the area coverage will be of course more, but the details we are unable to identify. For example, in a aerial photograph, when you talk about 1:5,000, so details what we find there is clearly we can identify the building, clearly we can identify the roads, clearly we can identify the objects on the Earth's surface. When you see about 1:50,000 map, there we cannot identify the buildings very clearly, but the area coverage it will take more. Right? So in the next slide, I'll be showing you how it looks like. So it's important to consider the scale when interpreting features of measuring distances on aerial photograph, as it directly impacts the level and detail of accuracy information represented. So now this is how it looks like, small and large. These are two examples given here. When you talk about small scale and when you talk about large scale. So large scale means you can see in this portion, this is the large scale map. So what are the details we can see in the large scale map? See, you can see the parcels here, right? Very clearly parcels we can see here. This is how we can see. But whereas in the small scale, these parcels we can't see. Only major details we are able to see. Major details means we are able to see the lake we have here, like we have different kinds of roads, we have different kinds of residential areas. That all we can see, but with a very less details. But whereas if you go to the large scale map, you can see the very clearly the parcel lands here, right? Here. So this is how it looks like, large and small. So again here one more example is there. So this is large, this is small. So now you can see in the large scale map, the area coverage is always less. It means that if this is a part of this map, then this much portion it is represented here. Okay. If this is a part of this map, let us say this much portion is represented here, not totally. Okay. So if we represent the entire area, this area is small scale. Why? Because it is giving you very less details. Whereas here in this portion, you can see lot of details you can see here. We can see the parcel boundaries here again. You can see the land again here, and lot of details we can see, your village we can see. But here in this maps, small scale map, its area coverage is very much bigger. Whereas details, here details you can't find, here details we can't find, details we can't find. So we cannot find the parcel areas in this maps, right? So basically the large scale map will show you the entire information of the ground, very clear picture of the ground. So as for the aerial photograph, when the scale resolution is very much high, when we talk about large scale, there we are able to see very clearly the buildings, very clearly the trees, very clearly the objects on the ground surface. When you talk about aerial photograph, when it has a small scale, there we cannot see this all buildings. We can just broadly classify, and we can just see the huge classification, broad classification, right? You can see the forest area broadly, we can see the water bodies, but we can't see clear picture of the ground. So this is the difference between scale and small scale and large scale. Now here we have one more example here. It's more clear, it is given here. So this is one small scale, large scale. Now just now in the before slide, I told you about large and small. Now this is one part of this large scale. This large scale is one part of the small scale. Okay. So if this is the small scale, so this much portion it is showing here. So to cover with this large scale, to cover the entire area with this large scale, what we have to do, we have to collect different number of sheets with the same resolution of the scale. Okay, so suppose this is sheet number 1. So to cover this area, we have to collect sheet number 1, sheet number 2, sheet number 3, sheet number 4, sheet number 5 and sheet number 6. Maybe total with this large scale, total 6 sheets if you collect, then it can complete this entire area of the small scale. With large details, with detailed information, it can complete this entire area. So this is the difference between large and small scale. Now here you see 1:20,000 you have a large scale, 1:2,50,000 you have a medium scale, and 1:, this is a smaller scale, right? So here 1:20,000 in this map you have very large scale map. Large scale map, you can, what details you can see is, you can see the contours here. Okay, you can see the contours. You can see the area covered here, and in this medium scale, what you can see the roads, you can see the rivers. Okay, whereas in the smallest scale map, the entire area where it is covering, there you can see major cities, only the major cities, the name of the cities you can see. Okay, so this in this city we cannot see the details. So this is about the small scale area, means the area coverage is very bigger. The area coverage is bigger and there is no detailed information. No detailed information. Whereas in the large scale map, area coverage is less and more detailed information we find. Okay, so this is the difference between small scale and large scale. We can find more details in the large scale map, and we can find less details in the large scale map, more details and less details in the small scale map. Okay, so next you can see, if you want to see the difference of this, these maps show the large areas in less detail, these maps show the small area in more details. Various relief features like sea, mountains, valleys, etc. are shown in these maps in the small scale. Means it is a broad classification. Whereas in the large scale map, you can see these maps show details of cities, towns, villages. Okay, here we can see cities, towns, villages. Whereas in this small scale, you can see mountains, valleys, sea, major things we can identify. Whereas in this large scale map, we can identify small things like cities. Inside the cities, you may have the building information, you may have any other object information you can easily identify. Now the scale may be 1 centimeter is equal to half kilometer. Here the scale may be 1 centimeter is equal to 100 kilometers or 1 centimeter is equal to 500 kilometers. This is the difference between large scale and small scale. Now different ways to determine the scale. So we have different methods. How can we identify the scale of the aerial photograph? So among this, we have different methods, different ways to determine the scale. So first method we'll see here, using ground control points. So what are ground control points? So let us understand first what is ground control points. So we generally call it as GCPs. So ground control points, if this is the map, this is your map area. So here we have to assign some points like latitude and longitude, x and y coordinates in this point, and this point, even in the center. So if you assign some points with a latitude and longitude information with x and y coordinates, that kind of information a GCP will be having, a ground control points will be having. So what it will do, this point will be having x and y value, that is latitude and longitude. Latitude and longitude. So x and y value it is having, each point like this. If you have 5 points, if you have 6 points, so each point will be having the x and y coordinates. So these coordinates are having the information of the ground. So what it does, when you put these coordinates on the map here, it controls the entire map. In sense, it will just assign, if you assign 1 point here, 1 point here, 1 point here, 1 point here. So if you assign this 4 points, what it will do, when you run this process, what it will do, your entire map will be having latitude and longitude coordinate system. So all the coordinates are assigned like this by putting the GCPs. So how can we determine the scale with the help of ground control points? So known ground features is like, if ground features of a known size are visible in the photograph, they can be used as ground control points. Like if we are not having a device, if you are unable to mark the ground control points, so in that case, if you know, if this is your map, suppose this is your map, and if you want to assign a ground control point here, so what we generally do, how do we assign the point is, just you have to find out the known size are visible in the photograph. Like a road and railway crossing is there, 2 roads crossing are there, T junction is there, Y junction is there. So like that, if you have this known points, you can just go to that location and you can just record the latitude and longitude of that point, and you can just assign in the map to assign the coordinate, to assign the GCP to the photo. So between these points on the photograph, comparing it to their known ground distance, the scale can be determined. Now, ground control surveys. Surveyors can establish ground control points with known coordinates. These map points can be identified in aerial photograph, and scale can be determined by comparing the distances in the photograph. Right, surveyors. So in this method, what happens generally is, if you have an aerial photo, this is your aerial photo. Okay, so what the surveyors do, the Survey of India will do, they will just survey the entire area, and they'll be assigning a control point over the map. So if a ground control point is assigned on the map by the surveyors, this map will be around 99% correct accuracy it will be having with the ground control points. So this map we can use as a reference for assigning the scale. Okay. Now next, it is one more. The other method is, the other way of determining the scale is, it's not method actually, it is determining how can we determine different scales. So methods I'll be telling you later. So photogrammetric information, with the photogrammetric information, how do we determine the scale? So like flight planning data, scale information is often included in the flight planning data associated with aerial survey. This data may include information on the altitude, focal length of the camera and other parameters during the survey. So in this kind of flight planning data, you will often see that the flight planning data always associated with the aerial survey. So aerial survey is done. Based on the aerial survey, we'll be having a flying focal length of the camera, we'll be having the flying altitude of the plane. So with the help of the flying altitude and with the help of the focal length of the camera, we are able to determine the scale. So it has a formula also. That formula I will tell you. Camera calibration, the camera used for aerial survey can be calibrated, and this calibration information can be used to determine the scale of the photograph. So we can just calibrate the camera, we can set the settings to the camera, and then we can determine the scale. So this is another way of determining the scale of the aerial photograph. Now the third way of determining the scale of the aerial photograph is stereo viewing. So what is stereo? First of all, let us know what is stereo. So here it is mentioned as stereo pairs. So stereo pairs means, if we remember in the first lecture, we have discussed about introduction to photogrammetry. There we have discussed about the different types of photos. How do we obtain that photo? So stereo pairs, how do we obtain the stereo pairs means, like if a flight is capturing the information, so what it happens, if it clicks photo number 1, again the photo number 2 will be clicked here, right? Photo number 2 will be clicked here. Photo number 3 will be clicked here. Photo number 4 will be clicked here. So this is 3, this is 4. So this overlapping area, we call it as stereo. This overlapping area, we call it as stereo. So overlapping can be around 60%. Overlapping can be 60%. It can be 70%. Right? So overlapping or forward overlap will be almost 60 to 70%. So a continuous series of photo number 1, 2, 3, 4, continuous series of photo. There, if you want a stereo pair, we have to take photo number 1 and 2. It should be in continuous series. Either if you want to take another pair of photo, you have to take 3 and 4. Okay, so photo number 1 and 2, it's a stereo pair. Why stereo pair? Means it has a stereo. Stereo means overlapping area in the aerial photo. So aerial photographs are often taken in the pairs called stereo pairs. Here it is mentioned again, with a certain amount of overlap. Viewing these pairs in stereo allow the depth perception and parallax effect can be used to determine the scale. So with this overlapping area, we are able to find out the depth perception. Like 3D viewing also we can find out, and with the help of that, you have a parallax effect. With the help of parallax effect, we are able to determine the scale. Next, you have a stereo plotters. Specialized in instruments like stereo plotters are used to measure stereo pairs by measuring the parallax shift of features between two images. The scale can be calculated. So the third way of determining the scale is stereo viewing. Stereo pairs we have to use. Next, we have a topographic map. So this is the almost best method of determining the scale. Like as we have discussed in the previous slide, this topographical map, the topo sheet, generally it looks like this. This is a topo sheet. Okay, this topo sheet. It has 4 coordinates here. 1, 2, 3, 4. Total 4 coordinates it has. This is the coordinates which is visible on the topographical map. Later you will be having more number of coordinates inside the map. So coordinate number 1, coordinate 1, this is 2, this is 3, this is 4. So you have 4 coordinates here. So left side you have left upper corner, you have coordinate 1, then right side you have coordinate 2, then down right you have coordinate 3, and again you have coordinate 4. So you have 4 coordinates on the map. So this topo sheet is having a information of, coordinate information of like latitude and longitude. Latitude and longitude. So it will give you the scale of the aerial photo. So like it has a scale of, let us say sometimes it will be 1:10,000, 1:20,000, 1:50,000. That all depends on the scale of the topographical maps, whether it is large scale or small scale. So here we have an overlay method. Aerial photograph can be overlaid on the existing topographic maps. So just now I told you, the topographical maps, it is a surveyed map and it is having the coordinates in all the 4 corners of its photo. And what you can do, if the scale resolution of aerial photo and topographical map is same, then what we can do is we can just overlay the map on the topo sheet. For example, this is your topo sheet. I hope you understood. This is the topo sheet, and you have, this is the topo sheet, and you have an aerial photo here. Okay, this is your aerial photo. Okay, so this is the topo sheet, this is the aerial photo. But in overlay method, what we do is, if the scale of this topo sheet is, for example, 1:10,000, and same thing, same features are mapped in this aerial photograph. So this aerial photograph, just you can overlay exactly over the topo sheet. If it is overlaying, you can just swipe and check. If it is overlaying, that means this aerial photograph features are mapping exactly to the topo sheet. So the scale is determined of the aerial photograph. How we can say means, if it is mapping to the topo sheet, that means the aerial, whatever scale our topo sheet is having, same scale aerial photograph will be having. So this is the overlay method we use in the topographic maps, right? Next you have GPS and remote sensing technologies. So in this you have global positioning systems, GPS system. GPS can be used to accurately measure the ground control points. GPS can, nowadays we are using in the navigation purpose. For any kind of information we are using the GPS system. So if you want to know the information about the location, we are going to use the GPS system. So GPS system will give you the latitude and longitude of that area. And so when these points are referenced in the aerial photograph, the scale can be determined. So once you assign, for example, this is the map and you have GPS points. So once you assign this GPS points to the map, then we can determine the scale. So this all information, all the methods when we can use when you have a software. Software like photogrammetry software or like RGS software, we can do that. So remote sensing software, geographic information system software can be used to georeference and analyze a aerial photograph. Like remote sensing software we have and GIS software we have. Remote sensing software what we have is ADAS, and GIS software we have ArcGIS, or you have QGIS. So we have different softwares where we can determine the scale in different ways. So this is one of the methods where we can just transfer the GPS points to the map after recording the GPS points in the GPS device. So where we can transfer this, we can use the software, GIS software we can use, ADA software we can use to transfer the information to the map. Now we have one more way of determining scale. This is very least method we do not use generally. It's like LIDAR method. So LIDAR is light detection and imaging. So LIDAR data can be used to create high resolution elevation model. When combined with aerial photographs, LIDAR can help to determine the scale by providing accurate ground surface information. It's like when combined with aerial photograph, LIDAR can be helped to determine the providing accurate ground surface information. It is having a very least it is used. It is not used generally. So these methods are often used in combination of enhanced accuracy and reliability in determining the scale of aerial photograph. So the choice of method depends on the available data. So as many methods we have seen just now, as many ways we have seen just now. So based on the availability of the data, if you have topo sheet, we'll go with the overlaying method. If you have GPS system, we'll go with this GPS method. If you have other kind of information, aerial photo information, stereo press, we'll go with the stereo press information. So based on the availability of the data, we are going to determine the scale in different ways. So these are all different ways of determining the scale of an aerial photo. Now I'm coming to the methods to find the scale. So what are the different methods we use to find the scale? So the concept of scale for aerial photograph is same as the map. As we have discussed in the first slide. So what is the scale? What is a scale? First, let us revise it. What is a scale? So scale means, suppose this is the distance A and B on photo. Distance A and B on the photo. Now, the same distance A and B should be measured on the ground. So this is ground distance. This is ground distance and this is photo distance. Photo distance. So for example, here you see scale is the ratio of a distance on an aerial photograph and the distance between the same two places on the ground in the real world. Okay, the distance on an aerial photograph and the distance between the same two places on the ground in the real world. Real world means the ground distance. Okay, real world is ground distance. So, for example, it can be expressed in or like 12,000 inches or as a representative fraction 1:1 lakh. Unit equals to like 1 centimeter is equal to 1000 kilometers. So 1 centimeter is equal to 1000 kilometer means this A and B which is on the photo the same. So this is between the two distance. This is distance A and B. So here on the photo it is 1 centimeter. So it represents this 1 centimeter is equal to 1000 kilometers on the ground. So this is how we represent. If we are measuring 1 centimeter in the photo, that means that it is equal to 1000 kilometers on the ground. So if you are measuring 2 centimeter on the photo, that means that is equal to 2000 kilometers on the ground. So scale is expressed like this. Same distance if you measure on the ground, that is in kilometers, meters, miles. That depends on the scale availability. So we just define the scale like this. If you take 2 centimeter, now if you determine this, to determine the dimension during the aerial photo interpretation, it will be necessary to make estimates of lengths, areas which require the knowledge of the photo scale. So now here if you see, scale is the ratio of the distance between 2 points of an image to actual distance between the same 2 points on the ground. Same information is here, like distance between 2 points on the image, to the actual distance between the same 2 points on the ground. So this is how the scale determined. So in the previous slide you have seen 1 centimeter is equal to 1000 kilometers. So like that 2 centimeter is equal to 2000 kilometers. So like that we determine the scale. The scale is an important describing factor of vertical aerial photography. The scale of the photograph is determined by focal length of the camera and flying height of the above ground. So there is one more way of determining, like with the help of focal height of the camera also we can determine. So what is focal length of the camera? Focal length is distance from the middle of the camera lens to the focal plane. So what is focal length? Focal length is like, if here is your exposure station, here is your exposure station, and you have a focal length here from here to here. So here will be your camera. So between this and this, it is called as focal length, right? So this is the flying height, and this is the camera located here. So from here to here, it is called as focal length of the camera. Now, methods to find the scale of the aerial photograph. So there are two methods basically. How can we determine the scale of the aerial photograph? How can we find the scale of the aerial photograph? So we have discussed in the previous slide also what is a scale. Scale is a distance of the on the photo. When 2 points distance on the photo, same distance on the ground is equal to, is called as scale. So method 1, scale is the ratio of distance between 2 points on the photo, actual distance between the same 2 points on the ground. So 1 unit on the photo is equal to x units on the ground. So if 1 kilometer stretch of the highway covers 4 centimeter of the aerial photo. Okay, so the scale of the vertical photograph is the ratio distance between on the photo and the corresponding distance on the ground. So now photo distance, this method is about how we can find out the scale. So photo distance by ground distance. So if you have a photo distance means this A, B, point A and point B, this is photo distance. Okay, this is photo distance, and point A and B ground distance. Okay. So what is a photo distance and what is a ground distance? So photo distance and ground distance, if your photo distance is 4 centimeters, so your ground distance is 1 kilometer. So your scale is 4 centimeter by 1 lakh centimeters. So like that, if you want to 4 centimeters by 1 lakh centimeter. Now if you want to convert the scale, so 1 lakh centimeter means 1 is to 25,000. Okay, 1 by 25,000 is your scale. Now method 2, scale of the photograph can also be calculated. If you know focal length of the camera, I was talking before also what is the focal length of the camera, and height, flying height of the aircraft above the ground level. So if the scale, if you have to find out, so this is one more method we can find out, F by H minus H. So F by H minus H. So what is F here, what is H here, what is small h here? So capital H here is flying height of the aircraft above the sea level. Now small h is height of the ground above the sea level, and F is the focal length. So focal length, distance from center of the lens to the film surface. Now h here is flying height of the aircraft above the sea level, and small h is height of the ground above the sea level. So now we have to see if the terrain is perfectly flat or plane at the mean sea level, then h is equal to 0. Now here you can see the focal length of the camera. So this is I was talking about the focal length. So film or focal plane. So here is your plane, and this is the flying height. This is the flying height. Okay, this is the flying height. So here will be your focal length. This will be the plane. This will be the lens. And between this two distance, you have focal length. So if you know the focal length of the camera, we are able to find the scale of the aerial photograph. And this is the optical axis. This is another point again. another point, and as it is a vertical scale, vertical photograph, because exactly it is vertical, so this is principal point, right? So this is how we can find out the scale with the help of focal length of the camera, f by h minus h. Now, if we know the scale of the aerial photograph, we can even find out the flying height of the aeroplane. How can we find the height of the aeroplane? Height of the aeroplane means this is the flying height, as I said before. So how much height the aeroplane is flying. So if you want to find the flying height of the aeroplane, then if you know the scale, we can find out. So for example, an aerial photograph of a terrain having an average elevation of 1400 meters and is taken at the scale of 1:7500. So 7500. So focal length of the camera is 15 centimeter. So as we have discussed in the previous slide, that if you know the focal length of the camera, we are able to find the scale. We are able to find even the height of the flying height of the plane. So the flying altitude above the mean sea level is. Now we have to find the solution. For example, average elevation is how much? 1400 meters. Okay. Focal length is 15 centimeters. Now you have 15 centimeter, you have 1400 meters. Now you have scale of 1:75,000. 1:75,000. Now let the altitude of the flying height above mean sea level be h. Now s is equal to f by h minus h. So what is h here? H you have to find out, that is flying height. Okay, so height of the ground above the sea level. So small h is height of the ground above sea level. Okay, so here f by h minus h is equal to 1/7500 is equal to 0.15 h minus 1400. So here finally we'll get a height of 2525 meters. So just we have to put on the formula. If we have this all values, we'll get the flying height. So now we have a flying height as of plane. Flying height of the plane is 2525 meters. Like that, we have one more example here. A camera having focal length is of 30 centimeter and used to take vertical photography of terrain having an average elevation of 1200 meters. What is the height above the sea level at which the aircraft must fly? So here also we have to find out the height of the plane. So now other way of finding, we have two ways here. One is f by h minus h. The other way is d by d. D by d is distance on the photograph by distance on the ground. So here we have focal length precisely measured with cameras are calibrated, typically expressed in millimeters. Now where s is the scale of the photograph, f is the focal length of the camera, h is the flying height of the datum, and small h is average elevation of the terrain of the datum. Now given data is here. In the given data we have scale 1:7000 and f, that is the focal length of the camera, is 30 centimeters. And h is equal to average elevation, you have 1200 meters, and h is equal to height of the aircraft. This we have to find out. So what is this? We have to find out. Now we have to just put on the formula, that is, what is the formula here? F by h minus h. So now f is 1/7000. Scale is 1/7000 is equal to 0. You have to just convert, it is 0.30 by h, capital H, minus 1200 meters. So you will get the flying height as 3300 meters. Okay, so this is your flying height of the plane. Right. So here one more example. Same examples you can see here again. A section line AB appears on the to be 10.18 centimeter on the photograph. for which focal length is 18 centimeter. The corresponding line measures 2.68 centimeter on the map, which is to a scale of 1 by 50,000. The terrain has an average elevation of 210 meters above the sea level. The flying altitude of the aircraft. Find the flying altitude. So find the flying altitude of the aircraft. How we can find is same method as we have discussed before also. S is equal to F by H minus H. So there are two ways again, map by ground distance. So flying height is, we have to find out. So same calculation if we given data is, focal length is 18 centimeter, photo distance is 10.18 centimeter, map distance is 2.68 centimeters. The average elevation of the terrain 210 meters. Let the height of the aircraft be H meter. So scale is 1 by 50,000. So we know that map distance by ground distance. So this is other way of finding the scale. So map distance is 1 by 2, map distance is 2.68 by ground distance. We have to find out. So you will get a ground distance of 34,000 centimeter. So flying height will be 1,340 meters. Okay. So also in this way also we can find. So these two ways we have with this map distance by ground distance we have find out. Now by F by H minus H. So 10.18 by 1340 is equal to 18 by H minus 210. So the finally we'll get a flying height of 2,579.35 meters. So hence the flying height of the altitude of the aircraft above the sea level when the photo was taken is 2,579.35 meters. These are the ways of finding the flying height. So two methods I told you, how can we find the scale and how can we find out the flying height of the plane. Right? So these are the references from where we can just refer these topics. So M. Anji Reddy, Remote Sensing in GIS, BS publication, New Delhi. And we have Fundamentals of Remote Sensing by George Joseph, University Press, Hyderabad. And these are different web links we have, like Archive and NTPL courses we have. Again, Archive and NTPL courses we have. So if you go through this link, you will get the content about this topic. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.